Okay, so now we'll talk about the distinction between serial and parallel processing. So I'm trying to make this things as concrete as possible because it's difficult to talk about the mind because the mind is such an abstract idea. So I use these sort of concrete examples to start, but I'll obviously try to weave this into the context of the mind. So the question of parallel versus serial processing is, do cognitive processes occur in a linear step-by-step sequence kind of fashion? Uh, we would call that serial, or are these cognitive processes, do they occur in parallel, or in other words, simultaneously? So serial just means simply sequential or one after the other in this context. So it means that the stages occur one after the other in a fixed order and that each stage is non-overlapping and independent. All right. So let's unpack that. I have mentioned this before, but non-overlapping just simply means that a given stage of processing cannot start until the preceding stage of processing has been completed. And then independent means that the duration of any given stage of processing has no effect on the duration of the next stage of processing. So to give you a concrete example of the process, imagine this robot arm right here, these robot arms. They create these, one of them creates these blue balls, and then the second stage creates this orange little cup and puts it on the blue sphere or blue ball, I should say. And then the next arm creates a sort of red thing, red cylinder maybe. So the blue ball with the orange cup and the red cylinder, I guess. Well, these are non-overlapping because the second stage of creating this orange cup cannot start until the preceding phase that created the blue ball has been completed. And likewise, the red cylinder cannot start being made till both the blue ball and the orange cup have been completed. So that's what that means by non-overlapping. And they're independent in the sense that no matter how long it takes to make the blue ball, it will take the same amount of time for the second stage where the to make the orange cup. So it takes the same amount of time to do that, regardless of whether it took a long time to make the blue ball or a short time to make the blue ball. So it'll take so in other words, it'll take the same amount of time to do each of these things, regardless of how long the preceding phase took. And so that's the idea of non-overlapping and independent. And now I'll give you a more contextually appropriate example. Imagine that you're searching for something in a visual display, right? It would mean that the amount of time it takes to search for the thing that you're looking for would have no effect on how long it takes to decide that the thing that you have selected is in fact the thing you're looking for. So there's a search phase and then there's a decision phase that are non-overlapping because the search phase has to happen and finish before the decision phase can start. And they're independent in the sense that it doesn't matter how long it takes for one to search for something. It will always take the same amount of time for me to decide whether that's the thing that I'm looking for, right? That's the idea. We could also use a picture naming task. So the amount of time it takes to select the phonemes, the sounds that constitute a word for an already retrieved word would be similar regardless of how long it took to select the word itself. But notice how the, in the picture naming task, if I'm trying to say retrieve the word dog, in order to do that, I have to finish retrieving the semantic concept of dog. And then in order to retrieve the sounds that make up the word dog, I have to finish retrieving the semantic concept that is dog, right? Or the word, I should say. And so in the right side, this is sort of my rendition of what a parallel process is. And it's sort of a concrete example. And so parallel just means simultaneous. In parallel just means you're doing you're doing some two things at the same time. Um, And so it's sort of a theoretical framework that would allow for multiple processes to be performed at the same time. So in the example on the right, the blue balls are being created, but the orange cups can also be created while the blue balls are being created. And then the red cylinders can also be made at any time, at the same time. So they're all happening at the same exact time. And that's the whole idea. So in the context of picture naming, right? Maybe you see a picture of dog, and then you start retrieving the semantics of the word, but you don't have to finish retrieving the concept that is a dog. Maybe you only retrieve parts of it, right? You've retrieved aspects or characteristics of dogs, like four legs, wags its tail, descendant of wolf. These are some of the things that you could have retrieved or could have been activated, but maybe you haven't actually retrieved the actual concept yet. And then now, before that happens, you start retrieving the word. Well, maybe I don't have to actually complete retrieving the retrieval phase of the word of retrieving the word dog. Maybe I can, right? I can still retrieve some of the phonemes prior to retrieving the full word. So in this case, the phonemes have some influence on what word I end up selecting. This, and I know I'm sure that this seems very weird to people. Like, how can you select the phonemes prior to retrieving the concept? But if you've ever had a tip of the tongue experience, right? So a tip of the tongue experience is when you have the answer, you feel like you have the answer to a question on the tip of your tongue, right? So if maybe the question is, what is a medieval science that is dedicated to converting metals into gold? Well, the answer is alchemy, right? But let's imagine if the alchemy word is on the tip of my tongue, but I can't quite retrieve it, right? Well, if somebody asked me, what does the word start with, right? I probably would have some access to some of the phonemes. So in the tip of the tongue state, some of the phonemes might be activated despite the fact that you can't retrieve the word. And that would be an example of parallel processing potentially. Okay, so in the next video, we'll talk about different types of representations.